Hey, so I just want to show you a quick workflow with regards to a search query relevance domain. Right? So when you're searching for a specific skill set, we want to evaluate whether the top candidates that are returned are relevant to the job at hand. So here I'm in my Labelbox catalog, and I'm looking at a data set of HTML files that I have referenced from my Google Cloud bucket. Right? And each HTML file, as you see here, references a specific search query about a skill that I'm looking for candidates. And we're going to use our annotators from around the world to evaluate the metrics of each candidate for these skill sets. So let's start back to Labelbox, and let's go ahead and look for relevant search queries that we want. So we can click on a specific data asset and view the corresponding metadata for that asset. So in this case, I included some components about the skills that we're looking for. And furthermore, we can use these metadata queries to search for clusters of topics that we want. So if I want things related to data, I can search for data, and it's going to query my metadata to return search queries that contain this skill set. So click on one of these, and as you can see here, this HTML file contains the skill set of data analysis. The next one contains a query about data engineering. So this is relevant to your annotators. We can just select a few of these selections, and we can use the similarity search to search across our data set and return all search queries that's relevant to data analysis and data visualization. Okay, so typically your annotators will have to also write down the names and descriptions of each candidate in addition to their subjective rankings and relevance of that candidate. That usually takes time, right? It takes time to write down their names and descriptions. So what we're going to do in this workflow is we're going to try something different. We're actually going to use foundation models to help us write a quick description and write down the names of each candidate so that we're saving a lot of time and we're not doing some of the busy work. Okay, so we're going to select all of our results. And what we can do here is predict with Foundry. So in our case, we're going to use some foundation models to help generate the names and summary overviews for each candidate. So we'll go ahead and choose a specific model. So once this has finished running with the preview, you can see here that it has successfully finished. And now for each search query relevance, right? So this one for data visualization, our foundation models, as you can see from the text below, is going to show the names and a quick description of the top candidates for this skill set, right? This foundation model is returning exactly what I entered in the prompt, right? Let's summarize each freelancer based off their skills, and let's do it in less than 20 words. We can also check the logs to see if there's any mistakes here. In our case, it looks like this model does a pretty good job. Hopefully this is going to save our annotators plenty of time. So we'll go ahead and submit this model run, and I'll come back with some of the results. So now I'm back in my catalog. Our foundation model has finished running. And now you can see here, right, for each one of my search query relevance, we're now able to get a quick overview of their names, of the top freelancers, right, freelancer 1, and the skill sets and summaries that they bring to the table. So now instead of having your annotators write this, which can take up plenty of time, they can certainly save time and use our initial predictions as a guide as they're determining their relevance for each specific candidate. So now your candidates can either save time by exporting these predictions as data enrichment purposes, or we can pass this over to the annotation project where your freelancers and annotators can edit each prediction, or use the predictions as a guideline for them to make their evaluations. So let's see how that works. So here's some data sets that we ran the model with. And now we can go ahead and send this to our annotation project. We'll select the project that our annotators are going to work with. Let's go ahead and send this to our initial labeling task. And we're going to include the model predictions by mapping our initial ontology with the ontology that's featured within our annotation project. So we can save this, determine the priority, and send it over. So once we have sent our images with their corresponding predictions, we can now head over to our annotation project that your annotators will use. And now we can confirm that the data rows has been added. And by adding our pre-labels, right, they can save plenty of time because we now have already populated these fields with their names and the descriptions of each individual. So they can use this as a context. They can edit these fields and make the best determination for each and one of the top candidates. So this is the process of annotating. You can use the data row details to get an understanding of the query you're looking for. We can use attachments to see the link to the actual URL. And of course, we can use hotkeys to speed up our labeling task. Furthermore, using our platform, we can go ahead and call on annotation teams from around the world. So you get to choose and pick which annotation teams that you want to work with, evaluate the results. So ultimately, your team can get annotations and impressions for your candidates based off of impressions around the world. And lastly, as a project administrator, we can get a holistic view of the progress of our annotators and their teams. We can see how many search queries are still yet to be labeled, which ones are in review, and which are done. We can also break this down all the way down to individual level. And of course, we can filter on the labels that our annotator has created. So we can filter on things such as consensus average and see which search queries have the most and least disagreements among all of our labelers within this consensus system. Furthermore, we can click on the workflows to see the initial stages of review for our workflow. And we can also use the performance dashboard to get a granular view of all of our annotation teams with regards to throughput, efficiency, as well as quality with regards to consensus. So you can see here the average consensus distribution, and we can group this by any specific individual as well. So we can click on a specific annotator's name, see the labels that they've conducted, the reviews, and the consensus distribution for that individual. And lastly, we have a robust SDK. So you can export all of your annotations between all of your teams in consensus formats so that you can calculate your own metrics in granularity. So let me quickly show you how this works. You can see here we're using the Labelbox SDK to get the results of our annotations from all of our teams. It's going to return that in JSON format. So let's break this down. So now we can convert that into a data frame format, right, with the search queries, the individual labelers that worked on this search query here, right? We're doing a consensus of 3, so there's 3 distinct labelers. Their individual consensus score, right? So now we can calculate individual statistics and deviations, as well as any of the answers that they have responded with. So now we can calculate things as individual with the lowest average consensus for those labelers that you think might be the most biased across the board. We can see the lowest average rating for each one of the top candidates, as well as those data rows with outliers. So whether that's one individual that's bringing the consensus score down, while being holistically agreeable except for that one individual. So hopefully I gave you a quick overview of how you can bring in data to the Labelbox platform for search query relevance, look for the right queries to hand over to your annotators, as well as use foundation models to give them a heads up by automatically deducting the annotators' names and descriptions automatically.